In today's video, we're going to be transforming points on a diagram, on a grid, just like we did in a previous lesson. However, there's going to be multiple transformations being done. Now, honestly, I like doing these, writing them out, okay? It just makes it a lot easier to organize my thoughts, especially when it comes to dilations and rotations. Okay, so what I do is I first figure out what the point that's on the figure, and then see what's being done to it and just write out all the points. So you're going to probably need some scrap paper when you're doing this, just to help you keep track of your thoughts. All right. So this point right here is 2, 3. So I'm going to write that 2, 3. That's my original point on the original figure. Now this is being reflected over the x-axis. So when it's reflected over the x-axis, being flipped down, so the y value changes. So that 2, 3 becomes a 2, -3. So I've covered it reflected over the y-axis. Now, when it's translated up 3 units, that means the y value goes up 3. So -3 plus 3 ends up becoming 2, 0. Okay, so -3 up 3 goes to 2, 0. So I write it all out when you do these, and you should get used to doing that as well, just to keep track of your thoughts. I know it's easy, kind of. It's a lot more, let's say, convenient to do it on the grid, but writing it out just makes sure you're keeping track of all those transformations. All right, let's take a look at another one. These are only going to be rigid motions. I'll throw in some dilations in a minute. All right, what's this point? 4, -9. 4, -9. Okay, so rotated to 180 degrees counterclockwise. Okay, I wonder if they're going to, I don't think that they're going to have any 90 degrees. Okay, so I'm going to change it to -4, +9. That's what happens when you change it, when you rotate 180 degrees. The changes of the sign. Positive becomes negative, negative becomes a positive. All right, then translated left 4. Translated left 4. That means this goes left 4. -4, left 4, not 0. It goes to -8 because you're subtracting 4 from, 4 from the x value. So -4, when you go left 4, you have to -8. Okay. I'm going to change that to a little like subtraction symbol. So -4 -4 is -8. So your answer is -8, 9. And you can check it. Yes, all this ink's in the way. Boom. Okay. I'm curious. There's got to be one with a 90 degrees. Maybe not. Let's see. Erase this stuff. There we go. Let's see. 180. 180. I don't think there's going to be 90. Okay. You guys are lucky. All right. So that's with rigid motions. Now, dilations. Okay. Want a nice whole number scale factor. Let's see if they have that. Okay. Maybe not. Okay. We'll start with this. Okay. Q is 4, 4. So I'm going to write it out. 4, 4. Now, when it's dilated with a scale factor of 2 around the, or 1/2 around the origin, half of 4 is 2, right? So you just multiply these by 1/2, multiply this by 1/2, and you get 2, 2. And then it's rotated 180 degrees clockwise. So that means you change the signs. So it's -2, -2. So that's my answer. -2, -2. Submit. Okay, let's do another one with a dilation. Okay. Let's clear the screen. Okay. Let's do, here we go. This one has a scale factor, dilated with scale factor 1/3. All right, so D is 3, -6. So I'm going to write 3, -6. Okay, so that's D right there. Now, a scale factor of 1/3. I want to do that in red. So you multiply this by 1/3, multiply it by 1/3, or basically dividing it by 3. So you get 1 -2. So that's after it's scaled down 1/3. Then it is. Did I miss something? I did miss something. Ugh. I missed the reflection over the y-axis. All right. So let's redo that. So 3, back to our negative, that point is 3 -6. So 3 -6. Okay. Reflected over the y-axis. There we go. Reflected over the y-axis. That means I change the x value. Y value stays the same. Then I scale it down with the scale factor of 1/3. So just a little bit of change, but it's good to see that. And you get -1, -2. All right. So it was close to what I had before. And I actually, with those transformations, didn't matter the order. You could have done it, the dilation first, then reflected, and you would have got the same answer. So I could have stuck with the other answer I did before, and we got the same thing. So we have -1, -2. All right. One more. Clear, clear, clear. Clear, clear, clear. Wish they gave a 90 in this one. Here we go. Okay. This one is dilated with a scale factor of 1/4, then rotated 180 degrees. So my point here is 4, -8. So 4, -8 is being scaled down 1/4, right? Scaled down 1/4. So I multiply this by 1/4, multiply this by 1/4, and I get 1 -2. That's what happens when it's scaled down. So it would be right there. Bam. Then it's rotated 180 degrees counterclockwise. Doesn't matter what direction goes, counterclockwise or counterclockwise. I change the signs. So instead of +1, it's going to be -1. Instead of -2, it's going to be a +2. So it's going to be -1, +2. All right. So that is how you do multiple transformations to a point. Again, you're going to need to write them out. Okay. It makes it a lot easier when you do it that way. And then it could just verify with the graphs. Okay. Some of them, maybe the rigid motions, you can do by just doing them on the graphs, but definitely writing them out is another great valid way to do that, especially if you get a rotation of 90 degrees, which maybe Delta Math doesn't do, but I might do it, okay, on a quiz or a test or any of that stuff. All right, so that's it for today's video. Thank you for watching, and always remember, whether you're solving for X or Y, always give math a try.